Hello everyone, this is Rona from eMaint Enterprises, and thanks for joining us today for this month's Best Practices webinar. And as you know, as a software provider, eMaint, who is now part of the Fluke family, offers quite a wide array of different webinars and educational workshops. But for our Best Practices webinars, they're a little bit different. We focus a little bit less on product training and a bit more on the strategies, maintenance strategies. And toward that end, we invite in a variety of subject matter experts from different disciplines to share their expertise. And I'm really pleased today to have back with us, I should say, one of our most popular speakers, and that's Frederic Baudart, who is a lead product applications specialist with Fluke. And he's going to be presenting today's topic, which is focused on condition monitoring and specifically thermal imaging, using thermal imaging and remote sensors to enhance your reliability program. And Frederic, if you want to advance the slide, I'll go ahead and introduce Frederic for those that don't know him, and I know for many of our clients, you have met him before, but Frederic has degrees in both electrical and instrumentation engineering and has spent over 20 years in field service engineering and in preventive maintenance in a variety of technical positions, installation, commissioning, as well as service management roles. And he also is certified level 1 in thermography. And I know, hi Frederic, thanks for joining us today and taking time out of what I know is a very busy travel schedule to present today. But Frederic, I know how passionate you are about this topic of thermal imaging, and maybe you can speak a little bit to why you decided to, of all the topics you can present on, why you chose this particular topic to present to our listeners today.
Sure. So first of all, good morning. The reason why I wanted to present this topic is that is really twofold. We have a lot of our customers who are starting to really dabbling and start to get involved with preventive and proactive maintenance, and a lot of them either have used or I would like to use some type of measurement, and often they either start with vibration or with thermal imager. I think it's getting more and more common to use a thermal imager because it's a great tools to find anomaly issues, and it really is a picture's 1,000 words. And I think then with some of the requests and asks that we have seen from customers, it's not, Fluke is heading into a direction, at least for me, where we don't want to be just a tool provider, but also a knowledge provider. And I think having the ability to provide some of the training, some of the discussion, the talks about some of the tools and solutions that we offer has really resonated with our customers.
Excellent. Well, thank you. I do see, Frederic, just in the surveys from these webinars, that how do I get started with predictive maintenance? How do I apply these technologies? That is very often an ask. So I think it'll be well received. So before I turn things over to Frederic for the main event, a couple of quick housekeeping items. We are recording today's session, and I'll be sharing a link to the recording with all of our listeners later today, along with a PDF of Frederic's slide deck. But toward that end, I have all your phones on mute so that we can capture a nice clean recording and share it with you. But Frederic has agreed to stay and answer any of your questions that we can throughout the top of the hour. So please feel free to type your questions at any time into the questions panel and go to webinar, and I'll read them to Frederic at the end, or if we run out of time, we'll get you answers after the session. Okay, and we'll also be posting a link to the recording on our website and for eMaint University. All right, so I'm going to turn things over to you, Frederic, to get started.
Okay, so I'll move on. So one of the reasons also that I want to mention as we look into the agenda is that not knowing where some of the people who are listening are within their journey in terms of reliability, or even if they even use thermal imager, I wanted to bring back kind of I wouldn't say some of the basic, but really some of the benefit and applications on thermal imager in general. And then I will talk specifically or more about if you had a handheld versus wireless thermal imager, because there's actually some wireless thermal imager sensor. Then you can start doing some condition monitoring. And then we'll talk slightly about how does it fit within the strategy of proactive maintenance and kind of bring it back together. So one of the ways that we, at least within a company, we like to present the infrared is with the 5 why, which is who, what, where, when, and why. And this is how we approach a lot of our customers on why really, who can benefit from thermal imager measurement, what are the benefits, when is it used, where, and by what. So I'll go through this, and I think then some of you have already used thermal imager. You'll definitely recognize why you're doing this or how you're doing this, and some of the other, hopefully, it'll be new. So who can really benefit? So when you think about it, on who use thermal imager at any level, then you just starting using thermal imager either for basic troubleshooting, or you're doing truly troubleshooting on a higher level with a PM, proactive maintenance, and route base. There's a wide variety of people that we actually provide some of these tools or actually utilizing. It really goes from electricals to mechanical to process to building diagnostics, R&D professional, a utility engineer. I mean, there's a wide variety of people, and each of these people have truly different needs. So what it really means is that thermal imager on itself, the measurement, it really is for just about anyone who has a need to use this type of measurements, this type of parameters. So it really does not, you don't have to be a specialist, you don't have to be a level 1, level 2 thermographer in order to use. Although eventually, as you move towards using that tools more often, it would be great if you can attend. But that being said, there's a lot of our customers who simply use this to do route base, and they're not level 1. So it really makes this tool fairly straightforward and easy to use from the beginning. What are the benefits is there's a series of benefits that goes with thermal imager. I think the obvious one, the number one, is that you're away from any of the measurement you make. What I mean by this, it's a non-contact. So you could be 20 or 30 feet away, and it keeps you in a safe distance from any of the equipment, who potentially could be dangerous, could be hot, or could be really cold. It does quickly identify some of the troubles area. You can walk around even in a room or in a facility and point the thermal imager at multiple assets and quickly scan where potentially you would have an issue. There's a good picture right here of, I think it's a paper mill, a roller, where it shows you really the indication on where the cold spot and the hot spot are. And I think that's fairly representative of what you would see on the multiple applications. It's really easy to take. It's point and shoot often. It's really a non-destructive testing, so you don't have to change anything in your process. And then use some of the training data for predictive and preventive maintenance methodology. So it really is, often we try to tell our customers, hey, start using this thermal camera, feel comfortable about taking some of the pictures, and then include this into your proactive or maintenance program. And I think that will help you to move forward. In terms of where it is used, I have yet to find an application where I can really use it, to be honest with you. I think that there's so many applications from industrial to manufacturing to commercial building, residential dwelling. I know my home inspector last year when he came to my house brought his own camera. And so it's a wide variety of applications that you can do with this. And I try to often challenge myself to find new ones than I haven't tested yet. But essentially, when you think of it, there's no real limitation on where you can use this. The when will you benefit is there's a few of them. Obviously, the food and beverage application where you cannot touch any of the foods is quite a bit of been attractive for some of our customers. The rotating equipment goes without saying. So the motors, the pumps, and so forth, being away a few feet away and take the measurement is a big one. I do this quite often now with a lot of our customers and try to help them. High temperature equipment, you want to stay away from high temperature equipment. So by having the ability to measure this remotely and take a picture far away or close away, then you're not in danger, has a big attraction. And also see the variation of the temperature. It's not necessarily high temperature, but it could be really cold, or it could be a change in temperature that varies. Hard to reach applications. So often when you go to a facility, distribution center are notorious for that, where they have smaller motors. They're not necessarily easy to reach or to see. And so, or if they're way up high, that may be a way then with the camera, you can look at it and you can monitor some of these changing condition if the roller on the motors or the bearings on the motors start to go bad. And last but not least, really, the high voltage equipment. I think that goes without saying. Then obviously you have to have the proper PP for any of those. But high voltage equipment with a utility substation is a big interest for our customers, to be far away, stay outside of the substation, but you got to be able to see the picture clear enough to make a decision of do we have a problem? Why is the isolator overheating? What is the issues? The why kind of encompass the what I've just talking about on the previous 3 slides. It really is, it's about safe inspection methods, and I think that goes without saying, is that there's too many situations where potentially are dangerous, where we have to actually be very close to the equipment, and you could have an arc flash, you could have a release of liquid, hot or cold. So many situations with an infrared camera, either handheld or wireless, remote, you can actually be away from the equipment and still see as close as possible. It's really, it's reliable. I've never had any issue with a camera so far. Knock on wood, obviously. It's fairly quick. And what I mean by quick is that you can do a raw base in the morning, capture maybe 30 or 50 pictures, and once you've done this, capture the picture, go back and upload this on the cloud or on your computers. And so you can move from equipment to equipment fairly easily and trying to remain safe at the same time. Obviously, reduce the risk for you to be in danger, and it lowers the cost and tend to increase the productivity. What I mean by increase the productivity is that you will have your technician or reliability engineer spend less time trying to figure out an issue, and if you can have an established route base as part of a proactive maintenance, it will be able to use this camera and move fairly fast. So you don't have to spend so much time staying on one particular asset and then move again to the next one and spend double the time. And I think to a certain extent, you can prevent, and the idea is to move from really a reactive to preventive and proactive maintenance. And obviously avoid downtime. There's a situation where avoiding downtime is critical. And there's one that come in mind is that the recent facility had a small vibration program they were putting in place with a bunch of chill water motors and pumps, and they were really focused on the vibration program, and they were doing this on a regular basis. And I told them, have you ever considered also using in conjunction with your vibration, you should use thermal, because not all issues are related to vibration. And they said, no, we have not. They start using it, come to find out that on one of the motor who was showing some decent vibration measurement was showing much worse picture in terms of the infrared. And it come to find out that it was not a vibration issue on one of the motor, it was an electrical. And so having the ability to combine multiple parameters, as an example of vibration and thermal imager, really show the entire picture on how you can find. Another example right here, then we have taken, then I've shown right here, it has to do with a school. So it's really, a lot of school companies and businesses use steam, and they use steam trap to get out of condensation within the steam line. And so if you think about this example that we've taken, if you have a failed traps, potentially, then you have left for either days, sometimes weeks, or month. And if you're roughly, it's an arbitrary number that we took, but if it costs you about $170 per day, if you let that go for a year, that's about $62,000. And obviously, if you have multiple traps that fail, that can start to really have a big impact on your budget, on your cost, overall cost. And so, with the ability to look at this from a thermal perspective, it really gives you a different pictures, and you can actually try to resolve this a lot. There's another picture a little further on the application in HVAC that I will show. They really show, I think it's a seam trap as well. They show really the difference between, hey, it's working on the right side versus on the left side is completely clogged. So when we talk about industrial application in general, there's really a number of location, if you want to call, then we can use thermal imager. There's, if we go from left to right, there's obviously the HVAC. That's a big one that we can use, and it could be indoor and outdoor. Electrical distribution with substation within a facility or truly within the utility, like the PUD facility. Mechanical, I think it kind of goes without saying, all motors, all rotary equipment. Process equipment, so we tend to think about it has to be a rotating piece of equipment or high electrical powered, but processing equipment such as valve, such as pipes, tanks, all of these are also critical. You know, one of the things that I never really knew until I went to the training is that really it has a big impact on tanks. I never thought about measuring tanks with an infrared camera until we start talking about it, and you can see the tank level depending on when during the day you are measuring this. So there has a big impact. Same thing on piping. Is my pipe full? Is there restrictions? Is my valve properly working? The other aspect really is the building envelope. And building envelope could be a roof, it could be windows, it could be walls. Often we take the example to our customers and say, hey, you know, sometimes you can look on the renovation, or any kind of a house. You can see if there's cold spot in that wall. Maybe you don't have an insulation, or maybe there's an issue right here. So more and more, especially home inspector, are using this, as well as third-party contractor using this to really enhance either some of the building construction they're doing, some of the work, or simple inspection. So over the next couple of slides, what I wanted to do is really show you about some of the applications. The picture's 1,000 words for me, and I think for all of us, it goes along. So From a mechanical standpoint, there's a wide variety of applications you can go through. Electrical motor seems to be one of the fairly common one, but you can also have hydraulic pumps, belt. This is one of the ones that I don't often use this, but when I do, and it does show, you can actually see really a difference in if your belt is overused or is about to worn out or just about to break. Compressor, either normal conditions or bad condition. And again, this is also, when you think of infrared, it's not only about troubleshooting. It's also about either you do a baseline or you can do commissioning. There's a lot of things has to being said about, hey, what does good looks like from the get-go? And this way you have something to refer to you when you start having an issue or when you start looking at a proactive maintenance program, when you do a regular basis and say, 3 months ago I took this picture on this hydraulic pumps, and now 3 months after I have increased by 25 degrees, exact same spot. Okay, is there something in the process or in that piece of equipment that really changed? They show why should I increase 25 degrees. Obviously, couplings, this is a common one along with electrical motor or pump, then they will look at it. And roller bearings. I think roller bearings, a lot of our customers that I talk to, especially in distribution centers, large facility who have a lot of bearings and motors, is one of the key components that tend to fail, and they need to monitor. Once you have a roller bearing system that fail, it stops the entire process. It may not just be the motor, but it may be just the bearing. But if the bearing goes bad, you have to have the ability to actually see this. And there's very little parameters that you can measure on a bearing, maybe from a temperature standpoint. And so visually looking at the temperature and an increased temperature on your bearings has a big impact. From an electrical standpoint, there's also a wide variety of applications. So it could simply be a hot phase. If you look at an MCC, motor control center, you can obviously you can open see if there's one of the phase, then there's overheating compared to the other one. Substation with insulation, a connector at the top. That's a big one as well, which often have to be, the picture has to be taken far away from it. So you would use a camera, then you may be 50 or 100 feet away, but you still have to have some type of resolution that allows you to see this up close and personal, to see the difference in temperature or change in temperature or condition. Obviously, to either residential or commercial circuit and panels. See if you're overheating, undersizing some of the breakers. Fuse disconnect in industrial applications goes a long way. I think right there it's obvious. Then at the top we're overheating. So what does that mean exactly? Why we're overheating on that fuse? And bus bar in large industrial application facility will have a good use of this. So any electrical aspect can be used. Last one, we don't necessarily think of it as a primary one, but it really is an important one. That's why, for example, you start walking around the plant and you think of it first of all mechanical or electrical, but then you just start pointing the camera at all kinds of other application, and this is where you find some of these needs. Cement kiln, that's another one. Where's the hot and cold temperature showing the pictures on it. Tank level, as I mentioned, this is one of the one then taking at the right time and often early in the morning or on the evening will show you a difference where is your tank level be. Being in the top obviously would be the air. Steam trap, this is, I mentioned this earlier about the steam trap. This is really a big application for a lot of customers. A lot of a few universities have talked about it, more so towards the East Coast. Obviously, we don't have as much as customers on the West Coast or in general who are using steam trap, but obviously on the East Coast, lots of customers in various types of buildings, university, different centers and facility are using that. Well cooling, observer well cooling, that's another application then you can look at. I've had quite a few welders say, hey, can we use a thermal imager, because I really want to make sure that my welding has reached 300 degrees and I can go back down. Chiller operation, it goes without saying, then I actually use this quite often, even in our own facility when I work with the maintenance supervisor here, to make sure then it does not have an issue. So we walk around the facility, look under the chiller. I know this is a big one for a lot of facility from a operational standpoint. They just can't afford to have a chiller down, and so we're working, programs with a key arena, for example, where they have 2 chillers, they have to maintain all the time, and then they have an ice arena that goes very well with their programs. And last, as I mentioned, is really pipe integrity. So when you think of it as, I never thought initially about looking at pipes, say, is there any blockage, any issue with the pipe? Why is it more heat coming from this particular pipe? And it could be a valve blockage. And valve blockage, for example, is very difficult to monitor unless you truly have a vision, or you have a flow measurement. They really indicate that you have a reduced flow or different type of flow. And the last one is really about HVAC application. So this is on the bottom right, the picture that I had in mind when I talked to you earlier about. You can see on the right side, it's really one of the trap or the valve where is blocking, and on the left side, on the left side is blocking, on the right side is passing. We're also looking at coil in air conditioning. It could be industrial or it could be commercial or residential. I think when you think of it is that you have between ducting, insulation, steam trap, motor bearings, compressor. There's a wide variety of application within the HVAC application on itself. Because there's so many components, they include mechanical, electrical, and as well as a process on this one. It could be air leaks, moisture buildup. So it's not just if it's a hotter application, but what if you have more moisture? Component failure, missing point insulation, hot bearing belt issue. I mean, there's a wide variety of these. This is why I think it's a great fit to be able to use this in an application settings, in an HVAC settings. So I touched a little bit about the proactive. So we're switching slightly towards proactive maintenance. And what I mentioned earlier is really about why we're using this. And once you decide to have some type of program, regardless if it's a large program or a basic program, within even if you have 5 pieces of equipment, the idea is really to use the infrared handheld or wireless to do some baselining and trending and analysis. And that's how I kind of try to present to our customers. It is really great, and you can see really the value over time on having, number one, what is good looks like. And I think that's a key important factor. Often we tend to say, okay, well, we have a bad problem. Now we're going to start looking, but we have a problem. But we never know what was the reference. I mean, if that motor is 155 degrees today, what was it 3 months ago? I mean, we're still within spec, because we may think that it's overheating, but in reality, when you look at the spec, you're right in the middle of it. And I think so it's important. So as you start implementing a program, is that even to walk around the facility and using this as a tool to say, okay, let's decide what's good, what's bad, and then move forward and then establish a program. So you start to establish really a baseline. And then I think the second thing is, it's just like everything, just like when you decide to, I'm going to lose weight. Well, everyone can lose weight, and I can see this by my personal experience. It's great. We can all lose 10, 20, 30 pounds, hopefully. The hardest part is really to maintain. to maintain that loss of weight. And again, here it also has to do also to maintain some training over time. And so when we talk to customers about establishing a program, is say, look, do this on a constant basis, always at the same time, same application, and almost same physical location. So if you look at a motor, maybe put an X in front of the motor 2 feet away, and that's where, regardless who's going to take the measurement, they're going to take a measurement almost at the same location, pointing at the same spot on the asset. And so you need to start trend this over time. And I think then you will see definitely some of the benefit on if you have an increase or decrease of temperature in a particular asset or locations. And then you can start making decisions on that one. And obviously the last one is analysis, and that goes, it really is, that's the reason we're doing this is, yes, the infrared technology and tools are one aspect, but what we're getting out of it is the data. And the data is obviously the thermal imager pictures. So that's how we make the decision on this. So a quick example on why this is a key one and why analysis goes a long way. We had this customers of ours who approach me and say, hey, look, we have all these tramway and this train. And so when they go back to the yards, we have 2 facilities within the city. One of them is 20 away, which is where all our engineering department is. And for them, every time then one of the tramway or the train comes back to the yard, it's the perfect timing for them to see if the bearings on those trains are still working properly, because obviously they've been working for a number of hours, so they want to monitor how well they're doing. The people in the yard downtown don't necessarily have the knowledge and the skills to make those decisions. So the ability for the technician to take an infrared pictures, upload to the cloud, and then almost within seconds or within minutes, on 20 miles away, the ability for the engineer, the reliability engineer, or mechanical, electrical, to make that decision, look at the picture on the computer, being away from it, and say, hey, you know, John, you need to look at this, or we need to actually take that car, that specific car, and it needs to go to further maintenance because it looks like the bearings are worn out, and we can't put that wagon, that train back in service. And so the ability to also have analysis that way from a remote standpoint has the true value on how you can resolve issues, find issues, and really enhance your proactive maintenance in general. So I think then on the next one, I've got a quick question from a poll standpoint. I really wanted to find out, I don't know where you guys are within if you use that technology. So I really wanted to find out which best describe the current use of a thermal imager technology. Some of you may have it, some of you use just a little bit, or some of you are expert and use it extensively either within a PDM program or on a regular basis. It does not have to be in a PDM program. So Rona, would you mind to launch the poll question?
Sure. So Frederic is, excuse me, the poll is open, and Frederic is just asking each of our listeners to just tell us where you are in this journey regarding the use of this technology. And it's always interesting to see how this changes over time. These answers will only be shared collectively, so there's no wrong answers here, but it also helps Frederic know, how familiar you are already with these types of technologies. All right, so it looks like we have about 70% of the votes in, so we'll give it here just a few more seconds for people to weigh in. And we'll go ahead and close them. And again, if those of you that have questions, we've gotten a few, and we're going to ask them of Frederic at the end of the session, but please feel free to type them at any time during the session. Okay, it looks like the votes are are in, so let's go ahead and share them. So it's interesting, about almost half, 47%, are saying that they don't currently have the technology but are interested in applying it. We hear that a lot. 42%, and this is great, are actually using it a little bit. Maybe they're dabbling or using it in a reactive mode and perhaps not as systematically, want to do more. And then 12%, that's very interesting as well, are using it extensively and have a thermal program in place. All right, back to you, Frederic. Any surprises there from your view?
Yes and no. I think you still have a good percentage who either do not have it for various reasons, or some who actually already start using it. And this is kind of going in line with what we're seeing it also in terms of what type of technology are started being used in a program, in a PDM or preventive programs. So it does not surprise me. I think there's a wide variety of people, and what it tells me is that there's a huge opportunity for them to actually learn about thermal imager in that aspect, you know, and this is maybe one of the presentation, and we may put together another presentation similar to this, because obviously when you have 63% of the people who do not have that technology, obviously there's a lot to learn about it. Now, interestingly enough, I would love to see the 12% increase or more, but I think that as we move forward, you know, over the next 2 to 3 years, we're going to see a shift where a lot more customers are going to have or going to use this technology, even some basic methods. So I'm not too surprised. I'm glad to see that you already have 42% of people are using it, which is great. So I will switch gear a little bit, and obviously a lot of the application and the first part of the presentation that I talk about were focused on thermal imager, but I didn't really mention if it was handheld or wireless. And so I'll shift a little bit gear, because this one here really talks about some of the capability you have with a wireless thermal imager. Obviously, most of you know the handheld, which is the most common, or even the one that you would have on your phone. And those are great, but there's also another type of a sensor that you can use, which is a wireless capability, which you start shifting from just doing preventive to really start to do condition monitoring, or at least remote condition monitoring. And so this is why I wanted to talk to you about this a little bit more. And this slide really shows about the condition-based maintenance monitoring. And really, this is kind of it is our journey at Fluke, but this is how really we have taken this journey from what customer have asked us to be. And what I mean by this is, so if you look at it from the workflow that we have, if you go from left to right, anything in the blue shows about all some of the wireless test tools that obviously that we have, but it could be a different type of manufacturer as well. The point is having the ability to take a picture with a handheld and wirelessly upload that picture or that data into the cloud, into either a work management, to do analytic and report, or simply to do asset management, has a great value for our customers. And then where does the wireless capability sensor fit in the condition monitoring kind of a program is really, for me, it's parallel to a handheld. It's just gonna go hand in hand. So you would have a technician, reliability engineer, or anyone may have already a program installed in place. And it could be a simple program, it could be an advanced program in their facility. And so at some point they're going to say, hey, you know what, we have these 3 pieces of equipment that really need to monitor on the long term. And when I mean long term, it's not just hours. It could be days, weeks, or sometimes even months. So in order to do this, there's only one way to do it. It's really with a sensor that is really, first of all, is wirelessly sending the data, but it's always mounted at the same location, looking at the same center point on the asset. And this is why a thermal imager sensor that can be mounted and leave it there can be your eyes, essentially, far away from the application. And you can see this remotely. So the aspect is, as part of what we have called in the fluid condition monitoring, really is the remote monitoring, is we're trying to enhance some of the capability overall than not only we have, but it is available on the market. And so some of the benefit then you would have, obviously, with a wireless thermal imager sensor, it kind of speaks to itself. First of all, if you put a sensor, leave it there. If it's far away in a room or you have enough room to monitor, you can actually multiple assets. And so you can look at two motors at the same time, two pumps. You can do center point on one or the other, or you can simply have a reference in the background. Obviously, the mobility and the flexibility to use this, to be able to use this. I'm going to use this for a week on this piece of equipment. I'll get enough data to do a baselining, and then I'm going to move to this other piece of equipment because I need to monitor this on the long term. And so for the next 2 months, I'm going to leave this the sensor right there, and I'll see if there's truly a trend of increasing temperature on the bearings on the front, as an example. And obviously, I think it's important to, anytime you have a tool, regardless if it's a handheld or if it's a stationary, to make it really easy to use. So if you have a 360 degrees bracket type of deal, if you have a gimbal, it's easy to install just about anywhere, along as with the installation, the setup. And I think that this is something that we tend to think of it as difficult, or it's a wall in front of us, is how difficult is it for me going to be to install this? I've never dealt with a wireless sensor, or I've never dealt with a handheld. Is it, I want to be able to use these tools, and it's not going to take me, 6 months of training to figure this out. And I think that's one of the big things. Then, as long as Fluke is definitely a leader in this, but other companies, we're trying to really promote the fact that how easy it is to use and to install in order for you to capture the data. And again, we're going back, and I keep talking about the data, is that if it's easy to use, then that's going to remove the barrier for you to want to use this more and more and get the right data. In terms of application, really is some of the focus currently, but I think it goes much further, is the tier 2 machinery. So there's a lot to say about the tier 2 machinery, where often we tend not to look at it on a regular basis, but it still needs some type of maintenance. Being within a few feet or a few meters away, obviously has the same safe benefit they would have with a handheld, except you stay there all the time. Industry really is, for me, I put this there, but come to think of it, even last night I was thinking that you can use it just about anywhere. I mean, it's just a wireless capability. As long as you have wireless capability, I think this will be probably a big topic this year and next year, is it how you convince an IT department or a plant manager then that will have a true benefit for you without affecting the security within your facility from a wireless standpoint. And I think this is why we're having the conversation with customers, not so much about the benefit of the thermal picture, but really much more about the safety aspect, because at the end of the day, we want to get the data. And I think that is the most important. We want to see the thermal imager tell us what to do, what we should do, and how to act. So I wanted to share a picture. For me is 1,000 words. So I wanted to share an example right here of a graph and data on a wireless thermal sensor. This is actually a real-life application. It just happened to be in a maintenance facility where you have chill water pump motors who had shown some issue from a vibration standpoint. And so we decided to install a sensor. And as you can tell, if you look on the left side, that's kind of a screenshot of the live measurement that I took. You have, it was every 5 minutes we'll take that picture. Obviously, you don't need to do this every 5 minutes. You can do this every hour or even further. But it gives you the picture right there as well as the graph, the trend. And I think that's important to be able to have the ability to look at both of them. Having notifications as alarms, which is a big, big plus right there, is a big plus as well. It tells you what the alarm are all about, when they actually occur. I had put a picture of what it looks like from the light picture, so the real picture versus the thermal imager picture, to kind of give you an indication what the motor looks like. And I think one of the key aspects really when you talk about wireless, anytime you do any kind of measurement remotely, and I think that's important. This is not just for the thermal aspect, but any kind of remote measurement, is having the ability to have an alarm push notifications. Because this is why we do this remote. One of the aspects we do this remotely is that if I can have an alarm, so I could be going on my way to work, or I could have multiple people on my team, and we all get a push notification, then somehow this particular motor has finally reached 180 degrees, and we need to do something about it. So we can make the decision right there, right then, and have a quick call on the way to work, on the way back from work, and say, okay, we need to act now, and not waiting until we come back the next day, we figure it out, then we're doing vibration or other measurement. Later on, there truly is an issue, and then we have a failure on this piece of equipment. So some of the advantage of a thermal imager sensor, wireless actually, I want to say, is really the troubleshooting aspect. I think it goes without saying right here. We want to do, along with also baselining, is really troubleshooting. We want to capture a series of thermal imager over either a short or long period of times, and try to analyze this picture. So do I truly have an increase or decrease in temperatures and changing condition? The versatility, which is really how easy it is to actually move, relocate, and install this. I think for me, one of the big factor really is the data correlations. And I talk a little bit about this when I talk the example about the vibration and the thermal imager was one of our customers who found the issue to be electrical, not vibration related. It was really is, we should see either the thermal, the vibration, electrical testing, or sometimes oil analysis, volt and amps. Anytime you take one of the measurements, it really is a great rule of thumb to not only use that particular parameters as the only decision factor for you to make this. It was clear for me, especially when I was a field service engineer for many years, then multiple parameters are a really great indicator and will reinforce if you need to take action on a piece of equipment or on a process that needs to be changed. So, you know, once you get an alarms, you can remote monitor either one of the assets, but looking at either the AC, DC temperature, power monitoring, along with the vibration and your thermal, often will give you a complete picture of what you need to do if there's something to do, or if the application or process work well. And obviously, one of the key advantages really is the mobility. So you can move the sensors because they're just battery powered or they can be on the AC. You just can't move them anywhere. So you can put them away from, especially some of those are actually mounted with magnets or with 3M tapes. So you can mount them temporarily right there, then you can move away. So they can be just anywhere in the facility. They don't have to be hard mounted and left it there. Application for some of those type of sensors goes very similar to the application that I talked earlier about for industrial application, which really motors and drives, process instrumentation, HVAC, small transformer, and one of the ones that I like, and I think then we see the more and more often demand is about it's pre-commissioning. So truly commissioning, pre-commissioning, where customer want to say, look, we just installed a brand new piece of equipment. We'd like from the get-go to have good data on what it looks like. Can we install some of these, along with hard-to-reach location? And I think that's an important one. So some of the benefit that goes with this is when you think of it about wireless infrared monitoring, and it could be to a certain aspect as well infrared monitoring on itself, is for me the remote capability, the ability to access the data anywhere from any place by really anyone. And what I mean by this, anywhere obviously is anywhere. It could be at the facility or outside the facility. It could be also from either a smartphone, smart tablet, your PC, multiple people. You can share the data. That has, by having the ability to be on the cloud, that has a big impact right there, and you can make decisions quickly. The thing then you don't need to install this hardware part of our process allows you to have a much less downtime, or you don't have to have a shutdown. So that means you don't need to stop the piece of equipment to be able to work, to either install a sensor within the line or install any type of a measurement. So that has a big impact on a lot of the facility, a lot of our customers in that aspect. One of the most important aspects for me, and you know, I was a service manager for many years, is the safety aspect. So safer employees. So as long as you can make sure then you stay away from the applications safely. Well, let me rephrase this. Not really stay away, then you can mount the sensor away from the application and still have an accurate measurement. That has a big impact. First and foremost is the safety of the employee. The push notification is a big feature. I think a benefit for this. Then you could have multiple people on your team, or you could be yourself, and you have multiple layers of notification than you can have. It really gives you, it's kind of your eyes and ears away from the application. So if there's truly an issue, you'll be notified and you can make a decision. You or anyone on the team can make a decision. I talked a little bit about already accessibility, which is really about you can mount wireless infrared sensor just about anywhere when you think of it. It does not have to be in a particular location. Sometimes it could be in a place where it's really hard to reach, and you want to mount this. So you may not be able to, or you could not, if you had a handheld by itself, infrared camera, stay there for much longer because either it's too cold, too hot, too dangerous, or there's just rotating equipment. By leaving a sensor there and stepping away from the application, you still get the picture, but without being in danger. And obviously, the golden ticket really, while we're doing this, is to capture the data and to start to do some basic data asset management. And obviously, you know, either with a CMMS, any kind of software capability, work orders, creations. This is one of the reasons that we're actually doing this and capturing this. And to be able to have a historical data over time is a really big impact for a lot of our customers. So the second poll questions, and I know we're getting close to the end, but I really wanted to find out what type of remote condition monitoring does your facility currently use or would like to implement? So you may not have one, but you definitely have an interest. And I put obviously a variety of measurement, but I'd be interested to see from your perspective which one you have an interest towards. So Rona, can you forward can you launch it?
Yeah, so we've gone ahead and launched the poll, and it occurs to me that we probably should have opened this up for several answers. It might just restrict you to one. So maybe you can tell us the one that you're most likely or most interested in. All right, and we'll leave this open for... can you also, well, one question just came in, is the sensor that you're showing, is that battery, can that be plugged into an outlet, or is it battery powered?
Both.
It can be both?
It's both. It's battery powered and also can plug into an outlet. So gives you the ability to do this for a few days, a few hours, or a few weeks if you needed to.
And are you continuously monitoring and then specifying the interval for storing the image, or are you monitoring, taking the image at different points? Does that question make sense?
We're taking when you set this up, you set this up an interval on when the picture will be taken. And so it could be a minute, 5 minutes, 10 minutes, 15 minutes, 30 minutes, I think up to an hour. I think there's some of them also will present with 12 or 24 hours. So depending on the type of application then you would have, you set up the interval and the sensor capture, essentially it kind of goes to sleep, and then every 15 minutes will wake up, snatch a picture, upload to the cloud, and then goes back to sleep, and it goes on and on.
Okay, so you're doing it on predefined intervals. Okay, well, let's go ahead and share our poll results here so people can see everyone's answers. It looks like 24%, or just about a quarter, say they're most interested in temperature, 11% in power, 21% in vibration, 43% in thermal imaging. I suppose we'd see the greatest number on today's webinar, and then 1% ultrasound. All right, back to you.
Okay, so you said 31% in thermal imager?
Yes.
Okay.
Thermal imaging, 43%, sorry.
Oh, 43%, I'm sorry. So obviously it's kind of a little bit biased because since we're talking about thermal imager, but that's great. I mean, that's great to hear. And I'm not surprised at all. I think then customers tend to be comfortable with thermal imager, more and more comfortable. And then obviously you have temperature and vibration. It kind of jive with whatever I was thinking about it. So seems to be in line. So I got a couple more. I want to move on. The last two really is, and I think I talk a little bit about this, is really when you think of it about a strategy to shift. So when you decide, or if you have already a preventive maintenance, what are some of the key strategies then you want to focus on, and how you shift from reactive to proactive? It really is, for me, there's often four types of shift. The first one, you need to focus on the failure modes. So you need to do, almost like a big map, and say, what type of failure do we have? How often does it happen? And so you do a big spreadsheet, and then you figure out this motor has so many failures, this is how we do, or this piece of equipment does not have that failure. It gives you really an indication where you need to spend your time and focus on it. Number two is buying from leadership. If your manager and your manager's manager or the plant manager is not going to be buying this and has not a belief, you may not get the funding. But I also tend to say that often it goes both ends. So we have a responsibility to provide the data to our managers and to the plant managers to convince them. On the other hand, I see a lot of plant managers or supervisors who do their own homework and truly are a believer and have a buy-in and eventually try to have their technician buy into the technology. So it really does both ways. Obviously, technology selection, this is what we're talking about. A lot more to come, and you will hear a lot more about wireless capability, data transfer that you can collect, because obviously we want to get away from just having a pen and paper. And the last one is really about skill enhancement. And skill enhancement for me is really about training. I think it's important, and it's not just training of the tools. Training of the tools is only a portion of it, and we're lucky enough then, at least within some of the Fluke product, we tend to pride ourselves to provide tools then almost everyone can use, or it's easy to use to start with. You don't have to be a level 3 to use these tools. If not, it just defeats the purpose. But training is also about knowledge of what you're measuring, and I think this is a big component. You can have the best tools in the world, but if you don't know what you are going to measure and how to measure it, it just defeats the entire purpose. And so having that knowledge, it's over time, obviously, but this is where working closely with some senior engineers, senior technician, or even some of the leadership, and vice versa, will give you the ability. to get that skill enhancement. And last but not least, and one of my favorite kind of slides that I like to present is really it kind of encompass what we talk about. Is really to think of it anytime you talk about any kind of program, preventive program. Start small, get some success, get a good tools, and then show your result. And those kind of goes in hand with what we talk about. So start a small programs, have some buy-in, use either some service, some report, select the right technology, the right tool for you. Or if you think that vibration is the right tool because you have a lot of mechanical, then go with that. But definitely select the right tool. And then collect all the data, review the data, and share the data. And I think that goes a long way in document your success. And I think that often the buy-in from leadership will come from a big documentation to success. And I saw this even as of yesterday. One of our largest customers say, "Hey, we start to have success on this, and then we're going to share this. It is going to really enhance our program." And I think that's it.
Well, thank you so much, Frederic, and I'm sorry that we ran out of time. We've received many questions about pricing and specific features, but we do have to be respectful of the time here. So what I'll make sure is we'll be sharing a link to the recording, and we'll make sure that everyone, either Frederic, a member of his team, or a member of our sales team, will get back to those people with specific product questions. But thank you so much, Frederic, for putting this together today. And thanks to all our listeners, we have quite a few of you, for joining in and for all of your participation. When I end the webinar, there'll be a brief survey, and please let us know what other topics Frederic and his team are such a wealth of knowledge, and what other topics we can bring to you that will really help you on this journey. All right, so we'll be following up with answers to your questions. Thank you, Frederic, and thanks to our listeners, and we'll see you all the next time.
Thank you. Have a good day.